These are the notes for 6.2 in Math 105. So the previous section we were talking about, we were defining what a polynomial looks like and how to add and subtract them, like to do all the common operations with polynomials. But now what we're going to do is we're going to do some multiplication of polynomials. And then in 6.3, which I'll do in this video as well, we're going to look at a simple case of dividing a polynomial. So, like I said in the previous section, 6.1, a binomial is a two-term polynomial. There's two of them right there. That's a binomial. This is a binomial. And a trinomial is a three-term polynomial. Those are two. This is a three-term polynomial. Now, like I said in the previous section, this is also a trinomial, but this is a specific trinomial. This is a quadratic. And if you remember, I said a quadratic is a trinomial of degree 2. If you look at this trinomial, this is degree 3, so this is not a quadratic. This is a specific trinomial that shows up a lot, and we're going to be looking at that a lot in Chapter 7. So, but before that, let's look at the next operation, which is multiplication. So, whenever we're doing multiplication of any kind of polynomial, we're using the properties of exponents, right? So, just to recall from 4.1, right? Recall from 4.1, when we multiply two bases that are the same, what do we do to their exponents? We add them. It may not look, I think I use b to the a power or whatever in 4.1 notes, but this is the idea, right? So whenever we multiply common bases, we add their exponents together. I just want you to remember that. So, when we're finding the product of the following, this is what we're doing. This is the main thing we're doing because we're doing multiplication. So, you multiply all the common bases together, all the coefficients together, and all the, like I said, all the coefficients and all the common bases, and you add their exponents together. So just go ahead and do that. So what's 4 times, so you just take it term by term, really. What's 4 times negative 2? That's negative 8. X to the third times x, now this is x to the first power, even though you don't see it. X to the third times x to the first, well, using this property, third times x to the first, that's just x to the 3 plus 1, which is x to the fourth. That's it. And then I have y squared times y to the 6th, so that's going to be y to what power? 2 plus 6, which is 8. That's it. Nothing to it. Easy peasy, man. So what about this one? I have a monomial, right? I have a single term. And it's being multiplied by a trinomial. So what do I do here? Well, I distribute to each one. That's what I do. So you just take it term by term. So 7 times 3 is 21. P to the second times p to the second is p to the what? 2 plus 2, which is 4. T to the first times t to the first is t to the second. That's it. Now that's this product. So now you got to do this one and this one, and then you're done. You're just distributing this 3 times. So the coefficients first, 7 times negative 2 is negative 14. P to the second times p is p to the third, and t times t squared is also t to the third. And then the last term, 7 plus 5 Well, I'm sorry, 7 times plus 5 is 35. P to the second times. Now there's no p here, so I'm not multiplying it by 0. I'm multiplying it by 1. So I'm just going to get p squared. And then t times t to the third is t to the fourth. So that's what I get when I multiply this out. That's it. Nothing to it. If I go to the next page here. So multiplying two polynomials. Well, I mean, we already did that, but so it just depends what kind of polynomials you have. Like the ones we just did was a single monomial times any other kind of polynomial, just doing the distribution law. But sometimes when you have, like in these few cases, when you have a hold on, I have to adjust my camera here. So whenever depending on the polynomial that you have, so in these few cases we have a product of different kinds of polynomials, not just a monomial. Here I have a product of two binomials. So like I say up here, we use the distributive law here, but it's a little different. And what do I mean by that? Well, basically all we're doing is this. We multiply each term from each polynomial, and then we combine like terms afterwards. So whenever I'm multiplying, this process right here could be described in a common way. You might refer to it as the FOIL method. So when I'm multiplying a binomial times a binomial, we're going to use what we call FOIL. And what does FOIL stand for? First, outside, inside, last. And that's what we do. So just if you look at it this way, what do we mean by first? Well, that's the first terms of each product. So this is the first term of that product, and that's the first part of this factor. Right? So these are the first. That right there is the F. The outside terms, that's the outside terms of each factor. So when I do that, the outside terms, this first term is also an outside term because it's outside. And that's the outside term of this factor. The inside is exactly what you think. It's the inside terms. The negative 6y and the 3x. I include the negative with the term. And then the last is the last terms. This term multiplied by the 2y. So once you go through that whole process, that's the FOIL process, then you combine like terms if there are any, and then you have the product. You're done. So let's do that step by step. And it doesn't matter the order in which you do this, but this is the best way to do it in. So 5x times 3x, that's the F part in FOIL. So that's going to be 15, right? X times x is x squared. 5x times 2y, that's the outside. So 5 times 2 is 10. Now again, remember, we're including the signs with each of these terms, right? So 5 times positive 2 is positive 10. And that's going to be x times y, which is xy. The inside, negative 6 times 3 is negative 18. Again, don't forget that negative. Y times x, well, yx, I'll write it out as yx for now, but you'll see in a moment yx is the same thing as xy because multiplication is commutative. You can multiply in any order you want. And then the last term, negative 6y times positive 2y. Well, negative 6 times positive 2 is negative 12. Y times y is y squared. So we're done with the FOIL process. Right? This is the first term. This is the outside term. This is the inside term. And that's the last term. which make up FOIL. But we're not done. We have to combine like terms if necessary. And if you look here, I talked about this. X times y is the same thing as y times x. So because of that, these two terms here are like terms. We could combine their coefficients together. So I have the 15x squared and the negative 12y squared. But negative 18 plus 10 is what? Well, you could use your calculator if you want, but that's easy. 10 minus 18 is just negative 8. So I have a coefficient of negative 8xy. And this is what I get when I'm all done. Alright, I know there's a big space here, but it's no big deal. That's the answer. So whenever you're doing FOIL, or whenever you're multiplying more, sophisticated polynomials, you're going to use FOIL, or you're going to use you're going to use some variation of the distributive law. This is one variation, but it only occurs when you have a binomial times a binomial. So in number 2, well, I do have a product of two binomials here, but I also have a 4x sitting out front. So I am going to use FOIL at some point. Now, can I do it first and then distribute the 4x in afterwards? Sure. I could multiply this in any order I want because, like we know, multiplication is commutative and it's also associative, right? You learn that in basic mathematics. You can multiply numbers in any order you want. So I can distribute the 4x into one of these factors first and then FOIL, or I could FOIL these two first and then distribute the 4x afterwards. Either way is fine. I'm going to FOIL these first. Alright, so since I'm going to FOIL these first, the 4x is sitting out front because I haven't done anything with that yet. And now I'm just going to put the result of this here, just like I did up here. So we're going through the same process with these two factors as we did with this in number 1. So x squared times x is x cubed. X squared times negative 3 is negative 3 x squared. Remember, the coefficient here is 1. You don't see it, but it's there. Negative 3 times 1 is negative 3. X squared. Now the inside terms, 2 times x is 2x, and 2 times negative 3 is negative 6. Now that I'm done that, just do a little distribution. Right? So now you're just going to distribute this into here, this into here, the 4x into each one of those 4 terms. Now remember, I could have combined like terms. Well, do I have any like terms in here? I don't. I have an x cubed, I have an x squared, I have an x and a constant. None of these are like, so I can't combine any like terms. These were like. These aren't. So I can't simplify this. I can't simplify everything in here any simpler. I can't. So now it's just a matter of distributing the 4x to each term. So let's do that. What do I get when I do that? So 4x times x cubed is 4 what? X to the first times x cubed is x to the fourth. 4x times negative 3x squared, well 4 times negative 3 is negative 12. And x times x squared is x cubed. 4 times positive 2 is positive 8. X times x, x squared. And then 4 times negative 6 is negative 24. X times 1 is x. That's it. That's it. What about this one? Now, this is a product of two trinomials. So, we're not going to use FOIL here. FOIL only pertains to binomials. These are trinomials. But we are using a variation of the distributive law here. So, and it really comes from this description right here. We multiply each term from each polynomial. So all you're doing is just you're multiplying the x squared by each term in this one. Multiply the negative 3x by each term in this one, and then the 2 by each term in this one. And once you do that, combine like terms, and you're done. So let's do that. So the x squared, you're going to multiply that by that one, and that one. The negative 3x, you're going to multiply by that, and that. And then the 2, you're going to multiply by that, and that. And then you're done. So let's go ahead and do that. So this could get a little long, but you know, it's really not that bad. Just take it one term at a time. X squared times x squared is what? X to the 4th. X squared times x is, what's the sign on that? It's going to be positive. X cubed. X squared times negative 5 is negative 5x squared. Now I go to the middle term. Negative 3x times x squared is going to be negative what? 3x to the 3rd. Negative 3x times x is negative 3x squared. Negative 3x times negative 5 is positive, right? 15x. Now I go to the last term. 2 times x squared is 2x squared. 2 times x is 2x. And then 2 times negative 5 is negative 10. So I'm done the distributing part. But I'm not done the problem because you have to combine like terms if necessary. And we do. If you look at this, you'll see there are like terms. I have an x cubed here. I have a 3x cubed there. So that's all the x cubed terms that are there. I have a x squared term here. Another one there, and another one there, and I have x terms, 15 and a 2. So combine them together, and you're done. So there's only one x to the 4th. Now, combine the coefficients of the x cubed terms. So I have 1x cubed minus 3. What's 1 minus 3? Negative 2 x cubed. I have minus 5 minus 3, which is minus 8, plus 2, which is minus 6 x squared. And then if I look at the x terms, I have 15 and 2, so that's 17 x, and then I just have a negative 10. That's the only constant I have here, so there it is. So after I combine like terms in here, that's what I got. And that's it. You know, I mean, this process isn't difficult. It's just you got to take it one term at a time. And be careful about your signs when you're doing these things. That's the big thing you got to worry about. So if I look at this one, now the square of a binomial, sometimes when you have, so the square of two identical binomial terms means we're multiplying the same two binomials together. That's why we could write it this way. So this is the same thing as saying a plus b times a plus b. Same thing. Their bases are the same, So we could, since they have the same bases, we could add their exponents together, right? Which is the base to the second power, right? So there's nothing, nothing surprising about that. So if I want to expand this expression below, we're just saying, multiply it out. So I want to rewrite this as 5x minus 4y, and because I have an exponent of 2, that means I have two factors of these, times 5x minus 4y. How do you multiply two binomials? You FOIL it. That's what this is doing right here. This is the technical term for it. I mean, this is what you get when you go through the FOIL process, but it's this FOIL process. It's the same thing. So just go through it. First, outside, inside, last. And this is a process that you need to get used to doing, and you get better at it by doing examples. And that's how you get good at doing these things. So the first terms is 5x times 5x, which is 25 x squared. All right, that's those two. The outside terms, that's 5x times negative 4y, so that's going to be negative 20, right? X times y is xy. The inner terms, negative 4 times 5, that's also negative 20. Yx. Negative 4 times negative 4 is positive 16. Y times y, y squared. And now, combine like terms. Do we have any? You betcha. Right here. xy times yx, they're the same thing. So these are the like terms. So that their coefficients combine together. So I have 25x squared. What do these combine to be? Well, negative 20 minus 20 is what? Negative 40 xy. And then I have positive 16y squared. And that's it. Now, in this one, in this particular case, I have a product of binomial conjugates. So you may or may not have heard of this term, conjugate, before. But a conjugate is basically, if I had a polynomial like 5x minus 3, so this is a binomial, right? Its conjugate will be, and I'll write it down here, it's just the opposite sign in the middle, so it'll be 5x plus 3. And you could do this for any binomial. So when I'm finding a binomial, the product of a binomial conjugate, I'm multiplying this by its conjugate. And mathematically, when you go through this, so if you multiply this binomial by this binomial, what you'll see is that the middle terms, when you go through the FOIL process, they're going to cancel out. If you compared this to up here, you'll notice that they're slightly similar, but well, they're different. This is a plus b, this is a minus b, but this is if I multiplied two identical terms, two identical binomials together. This one is differ by a plus or minus sign. And when you go through the FOIL process here, this minus 2ab or plus 2ab term, it drops out. So all I'm left with is a squared plus b squared, which is, or a squared minus b squared. And that's what I have down here. It just depends what you have. So if I look here, I'm multiplying two conjugates together, right? 3x minus 8y, its conjugate is 3x plus 8y. So when I FOIL this, like I have done, 3x times 3x, 9x squared. 3x times 8y is 24xy. The inner terms, negative 8 times 3 is negative 24. yx. Negative 8y times 8y is, well, negative times positive is a negative. 8 times 8 is 64. Y times y squared. So remember how I said a moment ago that when you multiply conjugates together, what happens to the middle term? It cancels out. And if I look here, what happens to these two? xy, yx, they're the same thing. But their coefficients are the same value, but they're opposite in sign. So what happens? They cancel out. It's supposed to be green, by the way, but it doesn't really, I don't know. I don't know if you can see that on here. This is 9x squared and minus 64y squared. That's it. So whenever you're multiplying conjugates together, you get a squared minus b squared term, which is what you have right here. So, you know, and again, you really don't have to remember that. You know, whenever you're multiplying a binomial, use FOIL. You're just using FOIL. That's the basic idea you should remember here. When multiplying a binomial, use FOIL. So, the last thing in this section is if you have, excuse me, if you remember from the previous section, we had the sum. So if you recall from 6.1, that's the sum function, right? And that's the difference function, right? And this was equal to what? F of x plus g of x. This was equal to f of x minus g of x. We also have a product function. Hey, here it is. So f dot g of x is equal to f of x times g of x. It's just a product function. So if I look at this example here, excuse me. If I have two functions and I want to find f dot g evaluated at 3. So, I mean, really there are two ways you could do this. There are two ways to do. So when you do this, you could, I'll do them both ways just so you see it. You could, well, you could find the product function between f and g first, which is up here, defined as f of x times g of x. And then once you find that, you could plug in 3 to the result and get your answer. So let's go through that. So f of x is what? 2x minus 3. And that's going to be multiplied by g of x, which is 4x minus 7. That's a product of two binomials, so we're going to do FOIL, right? So 2x times 4x is 8x squared. 2x times negative 7 is negative, what? 14x. Inside, negative 3 times 4x is negative 12x. And outside, negative 3 times negative 7 is positive 21. And if I combine the like terms, right, I'm going to get 8x squared. What's negative 14 minus 12? That's what? Negative 26x plus 21. So this right here is the product function. That's what this is right here. Sorry about that. I meant to write this. That's that better. That's the product function. But I want to find it at 3. So what could I do? I could plug 3 in here. So I could plug 3 in here. And so if I write that all out, that's going to be 8 times 3 squared minus 26 times 3 plus 21. You could do this in your calculator, and there's a really cool way to do this in your calculator. You could, I don't know if I talked about this in class, but you could store values in your calculator, and I'll show it to you right now. If you want to store things in your calculator and then type them into a function and hit enter, it'll spit out the number for you at that function. So I'm plugging 3 into this, aren't I? So what I'm going to do first is I'm going to store 3 in my calculator. So whatever your number is, in this case it's 3, you're going to hit 3, right? And then you're going to store it. So if you look at this button right here, this button, the STO, that's the store button. So if I press that, I'm going to get an arrow symbol. And then I'm going to press the variable button, which is right here. So then when I hit enter, now the calculator is treating x as 3. So now when I type in any expression involving x and I hit enter, it's going to evaluate that expression where x is 3. So if I type this in, if I type that in, and then hit enter, it'll evaluate this when x is 3. So let's type that in. So 8x squared, so 8x. You could square it, the square button's right here, or you could just do caret squared, either way is fine. Minus 26x, so minus 26x plus 21. Hit enter, 15. So the product function evaluated at 3 is 15. That's it. That's one way to do it. Another way to do it, and it really doesn't matter. I mean, sometimes it could get a little tricky if you do it this way, because this could get really ugly, but another way to do it is you could plug 3 into f of x first, and then g of x, and then multiply those two results and get 15. So if I do that, all right, because this is equal to this, right? So f dot g at 3 is the same thing as f at 3 times g at 3. So if I do it that way, what's f at 3? Just plug 3 in the 2x minus 3. That's easy. 2 times 3 is what? 6. 6 minus 3 is 3. What's g at 3? Just plug 3 in here. 3 times 4 is 12. 12 minus 7 is 5. And if I took the product of f of 3 at g at 3, that's the same thing as this, which is f dot g at 3. That's supposed to be a 3. Let me rewrite that. So f dot g at 3, well, you can see this is easy. 3 times 5, 15. It's the same thing I got right here. It doesn't matter which way you do it, you'll get the same result every way. So that's it for 6.2. You know, nothing really tricky about that. It's just, you know, again, when you're doing the product of two binomials, remember, use FOIL. Other than that, you're just using this property over and over and over again until you get sick of it. I'm going to do 6.3 in this video as well, because it's pretty quick. There's just one side to a sheet. That's it. And it's really not hard, because 6.3, we're only considering it's dividing a polynomial, and we're only really considering one case in this section. And it's only when we're dividing a polynomial by a single term, a monomial. And since b is going to be a monomial, we could do this. If it was not a monomial, we cannot do this. So this is only true when this is a monomial. If b were something else, like a binomial, trinomial, or any kind of other term polynomial, we cannot break it up like this. So we're only looking at one case like this, because if b were any one of those other kinds of polynomials, we would have to do what's called long division of polynomials, and that could get a little tricky. And that's not, well, it's not that it's tricky, it's just we don't typically do it in Math 105. So if you're going to go into Math 160 in college algebra, you'll see it there, definitely. But we don't do it in intermediate algebra. And it's really not that bad. It's just doing long divisional polynomials instead of numbers. And I don't think it's that bad. I really don't. But fortunately for you guys, you don't have to worry about it in 105. Not yet. So we're only looking at this case. I'm not going to look at, there are other cases, but we're not going to look at them in this course. We're not. So here, we're just going to break this up, because this is a monomial. It's a monomial. So I could break this up. And I could write it as 12 over 4, 12 next to the fourth over 3x minus 5x squared over 3x plus 6x over 3x. Again, you can only do this if it's a monomial. And now from here, how do I reduce this? How do I write this in lowest terms? Well, you should recall that other property from 4.1, right? If I have x to the a power divided by x to the b power, that's going to be x to what power? If I'm dividing common bases, you subtract their exponents. Just like if you multiply common bases, you add their exponents. So here, when I'm doing this, and you'll reduce coefficients as well, because if you look here, 12 over 3, what is that? What's 12 over 3? That's 4. X to the fourth over x, well, this is to the first power, right? So that's going to be x to the 4 minus 1, which is the third power, or 4x cubed. Minus, now 5 over 3, that doesn't reduce, so just leave it as 5/3. Fractions are okay. There's nothing wrong with fractions, guys. You're in algebra now. You're gonna get used to fractions. You just are. How many x's do I have? Well, x squared over x is just that reduces to x. So you could also think of it as there's 2 x's up here and there's 1 down here, so one of them is going to go away with one of these, and I just have 1 left over. Plus 6 over 3 is 2, and what happens here? Well, the x's cancel out, right? And that's the same thing, as this property, right? What's 1 minus 1? 0. What's x to the 0 power? Remember, in 4.1, anything to the 0 power is 1. So I just have a coefficient of 2 left over. And that's it. That's it. So, that section was really short, because that's the only we're only considering one part in this section, and that's it. Your homework on this section in MLP is pretty short. But again, when you go into Math 160, you'll see long division of polynomials. When you don't have a monomial down here, you have a binomial or any kind of other polynomial. And Yeah, that's it. So in the next video, we're going to start talking about, we're going to look at 6.4, where we start talking about methods of factoring. And we're going to start, that's all the operations where we did addition, subtraction, multiplication, and division. So now we're going to go in the opposite order. And what if I start with this? Or, for example, if I go back to my other notes, what if I start with this? How do I factor it? How do I get back to what I started with? And that's the process called factoring. And that's what we're going to do next. And that's what we're going to do for the rest of Chapter 6. We're going to look at all the different techniques of factoring, which in my opinion is the most important part of this class.